We're going to start off today with a presentation that's possibly the least technical presentation that you're going to get today. It's a high-level overview, and I'm not going to take it from the I'm not going to take the angle of telling you about all the Geode features, you know, async event queues and WAN gateways and partition regions. I'm going to tell you what people do with it. So my name is Randy May. I'm a Pivotal data engineer. Been with Pivotal since 2011, and pretty much every day since I started, I've been working with customers who have Geode systems, either helping, design, build, or fix their systems. So through the years, I would say some patterns have emerged. And so what I've done is taken and distilled all the systems I've worked on down into 6 common patterns, picked a representative from each one, and we're just going to go over those, and hopefully that'll answer. That'll show you what people do with Geode, and you'll definitely find out that it's much more than a cache. So here are my use cases. We don't have too much time, so I'm just going to jump right in. Okay, the first one I want to talk about is a hotel chain. So as you could imagine, if you sell hotel rooms, you probably are going to have a lot of systems that use property data. So property data is, pet policy on every room, how many beds are in the room, so forth. So, it's reference data for this customer. And the other thing about this customer is that they're globally distributed. They have data centers all over the world so that their systems are close to where their customers are. So we're going to talk about Geode in that context. So this is the first blueprint. Over on the left-hand side, let me kind of unpack it a little bit. Over on the left-hand side, you've got regional data centers. And of course, there could be more than 2. I've just drawn 2. And on the right, you've got the HQ data center. So the HQ data center holds a system of record for property data. It's just a database running on a mainframe, just like a lot of customers. Okay, and then in every data center, there's a conventional stack of application, service, and data store. And in this case, the data store is Geode. So far, pretty normal. So you could tackle this problem as a look-aside cache or a read-through cache, but this is a little different. So let me go through what happens with updates. So the first thing to note is this is not frequently updated data. And when it does get updated, it's generally not the sort of data that gets updated while a customer waits. A customer doesn't change the number of people that can, that can stay in a room. So it's okay for all the updates to just go back to the HQ data center. That's not the problem they're trying to solve. It's the reads. Every system needs to read that data, and it needs to be in region. Okay, so the way that we solve this problem is by, first of all, there has to be a mechanism to push the updates into Geode. In this case, that was a trigger. But then we use Geode WAN gateways to distribute the updates out to the regional data centers. So pretty simple. It's just kind of a twist on a cache, but it's got some nice advantages. A couple of them I just want to call out. One is, so in a look-aside or a read-through cache, you have to have an expiration policy. Your data could be old. And not only that, but when you do get a miss, you've got to go back and get the data from the data source. In this case, that could involve transcontinental hop, right? So that's a slow operation while the customer is waiting. So that's not good. So this solution is a little different, right? Because the way this one works is the data is served from Geode. Whatever data is there is served from Geode, and it's already as current as basically the network allows. So that's Geode as a global data cache. That's the first one. Second one I want to talk about is something that we're seeing more and more. I didn't even necessarily pick a specific system in this case because it's a pretty common in a lot of verticals. Okay, so it's Geode as part of a microservices enablement, or more broadly, just Geode as part of an agile transformation. So a lot of the companies that Pivotal works with have recognized the need for, recognize the value of agility. But it's not so easy if you're a startup, if you're not a startup. If you're not a startup, then you have a huge existing infrastructure, and it has to keep running, right? You can't just stop everything, refactor the monolith into microservices and start it all up again. You have to have a path to get from where you are to a decomposed microservices architecture. So there's a role for Geode in this. Okay. The funny thing about agility, this is going to come up a few times, is you have to kind of have to solve the problem all the way from beginning to end, from development to test to delivery, or else you actually don't see the benefit, right? So like if you can develop something in 1 week, but then it takes you 6 weeks to provision hardware and get it in your data center, then you got agile development, but you didn't see the benefit. So several things you need, right? You need, of course, agile development practices. You need you need a CI/CD pipeline so that those operations aren't manual, and some kind of platform that supports it. You need an architecture that allows your development teams to all work independently, not step on each other's toes. That's a lot of what microservices architecture is about. And then lastly, you need an agile data store. And just to convince you that I'm not just tacking that on, I went ahead and put the reference to the Martin Fowler article, so go check it out. It's really inherent in this microservices pattern. And let's look at why that is. Okay. So why do you need, just because you're using microservices, why do you need a separate data store? And the answer really comes back to what I said about, if you don't succeed in making everything agile kind of from beginning to end, then you don't see the benefit. So in a typical enterprise, you've got a lot of apps integrated on a database. And for very good reason, that database is subject to tight controls, right? So if a change to the database or a stored proc or adding a column is likely to break a bunch of apps, then I'm going to put some kind of change control board in place. Totally makes sense, but it's totally anathema to the project that's trying to do things agile and deliver in a week. So inevitably, you need to break away from that tightly governed database and get your own data store. Secondary consideration is probably that it seems like new development, they kind of prefer a NoSQL style, and a lot of legacy apps are just plain old SQL. But really, it's all about being able to actually realize the benefit of Agile. All right, so we end up with two data stores, and now we have a problem. We've got to synchronize the data, right? So this architecture is meant to address that. There's multiple ways to do it. But this is one that's emerged that's pretty common. And I think there's even going to be a presentation on this later. So I'm going to just go over it very quickly. This is kind of a combination of event sourcing and CQRS. And the way it works is that, so in this case, I've represented a profile service with a customer change, an address change operation. And rather than have that address change operation maybe directly modify a data store, instead, it writes a command onto an event stream, and then anything in the enterprise that needs to know about address changes can consume that and project it onto its own data store. So right there, we've managed to decouple things, which is what we needed to do. So the profile change command processor that projects changes onto the central database, that thing is subject to change control. That's fine, but the profile change command processor that writes things to Geode is not. Right, so that's one way to do it. Before I move off this pattern, another way to do it is that I'm kind of partial to is to go ahead and have the address change microservice write to Geode, and then use Geode async event queues to write the address change command over to the event stream, and everything else is the same. And what's great about that is that whoever made the address change, they get a immediately consistent view of the data, and everybody else who doesn't even know the address change occurred anyway, they get an eventually consistent view of the data. So that's another way to do it. So anyway, one way or another, it's not uncommon now for us to see Geode as a full data store as part of a microservices play. All right, so this one's really different, and this kind of goes back to the roots of Geode, and it's a rail ticketing system, and it's transaction processing. So clearly, a rail ticketing system is a very high volume, high concurrency system. If you think about it, somewhere in that system, every trip, every leg, and every time the train goes back and forth, there's a record that says how many seats have been sold so far. And if a lot of people are trying to ride that particular trip, then you've got a lot of contention on just one record, and this could be millions of people. Okay, so the other thing is, when I say transaction processing, I mean actual database transactions, right? Because this is exactly the kind of problem where you need to manage concurrent updates with transactions, or else you're gonna lose an update, and the business result will be, you sell the same seat twice, which is not good. Okay, so here's the architecture for that. So here I've actually broken out the Geode cluster. So across the top, we have app servers that are basically serving the transactions. The transactions here are looks and books, right? So looks are, can I ride this? Books are, I'm going to ride this. Okay. In the Geode cluster, we have the trips, the legs, and the availability for each one. And we have that split by line. Okay. So one data node's handling one subset of the lines, another data node's handling another subset of the lines. And we just have a Geode function to do the look or to do the book. And that Geode function, I've got that little breakout down there showing the code, pseudocode. And that Geode function actually updates the availability in a transaction, a Geode transaction. Okay, and so this is very fast. Now, just a couple things I point out before I move to the next one. First thing is, both the look and the book can be served without going outside of the data node, and that's key. The other thing is, that's kind of interesting, is by moving that transaction over to the server side, you can certainly, a Geode client can start and stop a transaction. That's totally possible. But by moving it to the server side, it goes from probably a few milliseconds to a few microseconds. It's 1,000 times smaller than, transactions hold resources. The longer a transaction is, the greater the opportunity for concurrent access, right? The greater opportunity for, concurrency. So moving that transaction over to the server side is a big part of this pattern. All right, better keep moving. All right, this is Geode for event processing. And the scenario I want to talk about is credit card fraud detection. This is, again, clearly has to be fast. It happens while the customer and the merchant are sitting there waiting. And not only that, that's only one part of the operation, right? The fraud check is only one part. You've got to do the banking stuff too. So it has to be fast, and it's very high volume. The process looks like this. This is not the blueprint. This is just about the process. So what we really want to do is we want to run a data science model that we have built offline, based on historical data. That's what we really want to do. But the input the information that's available on the card is not enough. So you probably have a card number, maybe a terminal ID, and an amount. So really rudimentary information. It's not enough to feed your data science model. You've got to augment that data with reference data. So as an example, turn the terminal ID into a physical location. Or maybe you need the total card spend so far today. You need to look that up. Or maybe you need the total maximum card spend ever in a day. So those are all called features. So we need to look those up, and then we need to feed that into the data science model along with model parameters and score it, get our fraud check. All has to happen in a few tens of milliseconds. Okay, so here's the blueprint for that one. So again, we are using Geode partition regions. And in this case, it's the card history that is in the partition regions. So, and we're partitioning by credit card number. So one data node handles a subset of the credit cards, another data node, another subset, and so forth. Okay, and again, we have a geode function involved. This time we've got something new. We've got replicate regions. So the terminal location data and the model parameters, those are, that information needs to be everywhere. It needs to be in every data node. Any credit card transaction could need those. So we put those in replicate regions so they're everywhere. And then we have a function that just does the two steps. It generates features and it scores the model and returns the result. Just want to spend a second talking about partitioning because it's probably the, why do we do it? And it's probably the most important decision that you make when you design a geode system is how we're going to partition it. And the main reason that the main guiding principle is I want the business operation to, I want to be able to do it to the extent possible using data that's only in the data node. And of course that's going to be fast, but it's not really about hops, it's really about sharing. So you need to so if you have a resource that is needed by all the transactions, whether it be a server or whatever, that thing is going to become a bottleneck. Didn't mean to do that. That thing is going to become a bottleneck. And on the other hand, to the extent that you can have all your transactions run independently, you're going to be able to scale that thing forever. It's just, if you're in that position, then it's like scaling a static website, right? Each web server has its own file system and its own copy of the website, and if you need to scale more, if you need to serve more requests, add more web servers, they're not even talking to each other, it's going to work, it's going to scale linearly. So same idea, that's what we're going for. Now, no system is ever actually quite that simple, but that's still the ideal to keep in mind. All right, next one, I think this is the fifth one. Geode is a data-aware compute grid. So with this system, this is a little different. The scenario here is portfolio performance reporting. So this is like what I'm talking about is the statement you get at the end of the month for your 401k. It says how it did. So this customer wants to offer that as a service, but they want to do it online instead. So obviously you need a whole different architecture if you're going to do it online, allow customers to slice and dice. It's no longer a batch operation. So that's the scenario. This is a little bit about the problem, just to set it up. So in the right, we have a grid of daily values of holdings. So every single thing I'm holding in my portfolio, I need its value for every day. That's how it works. That's the input to the rate of return calculation. So, so even if the actual holding doesn't change, then the value changes just because the price changes, right? So this thing, if the period of interest is large, like a year, then this thing could be kind of large. And then on the other hand, typical 401k, it doesn't change its holdings that often. So in the top left, we've just got a record of holdings, and it's just showing one holding, and it changes one time throughout the year. So in a in-memory system, we don't, this larger thing here, it doesn't make sense to store this larger thing in memory. So instead, we're going to generate it. And you can think of this as a lot like, you can think of this as almost like an in-memory MapReduce. So just once more, the process goes like this. So you got portfolio holdings history, you got daily prices, you stick those together to generate that big grid of every holding, every day, what is its value? Okay, and then that's the input to the rate of return calculation, and then you get your answer. Okay, architecture looks like this. So in this case, we have, again, of course, geode partition regions. And in this case, we're going to be partitioned by symbol. Okay, so each data node handles one subset of the symbols, and it's got the price history for, let's say going back 10 years for every symbol. Okay. Up at the top, we have a rate of return service. That's going to be input to the UI. The UI is going to pass holdings history, basically the portfolio. And it's going to pass that to the rate of return service. Rate of return service is a Geode client, and it is going to take and slice up that holdings history by symbol. So it'll send a slice to each data node as appropriate, depending on the data, what each data node is holding. So that's just something that Geode data aware functions can do for you. So the holdings are sliced and broadcast out to all the nodes. Each node then combines the holdings with the price history that it has, blows it out into a partial daily values grid, sends everything back. So that's sort of like the map part, but it's an in-memory map. And then finally, the rate of return service sews all that together and does the actual rate of return calculation. So this is the kind of thing you can also tackle with a data grid, but as contrasted to a data grid where you might have to spin up the process, or even if the process was spun up, you'd have to read the data in from somewhere, either over the network or from a file. The data's just sitting there already. So that allows it to be much faster, and it allows you to do what is really almost, at least was a batch computation. It allows you to do it online. So Geode for in-memory scatter gather. Okay, last one. Geode for streaming data. So this customer operates a fleet of trucks. And the trucks are constantly producing telemetry. So like where am I, engine codes, a bunch of stuff. And the challenge here is to write a system that allows the customer to leverage that and actually make some sense of it and answer business questions like, where is this truck right now? By the way, that's really important to them when they lose them. And has this truck gone off its route? So this is actually a very profitable system for them just in terms of finding stolen trucks. So anyway, the way this system works is as follows. So you have the information coming in off the cell networks, and it lands in a data center, goes through a data cleaning and transforming pipeline. One branch of the pipeline ends up in a data warehouse so that the customer can do BI and analytics. Another branch writes directly to Geode and to a telemetry region. So this is very high volume data. The telemetry region is partitioned by vehicles. So again, each data node is digesting a subset of the vehicles. Okay, and in this solution, the telemetry region is not really the point, though. In this solution, it's that current location and other aggregates. So these are things that are used to drive dashboards. Okay, so you could certainly imagine a dashboard with current location and anything else that they're interested in seeing in real time. So how do those get populated? So data lands in the telemetry region. Geode async event queues now are responsible for digesting that and computing summaries and generally just doing whatever they need to do to update the dashboard views. So telemetry comes in, it's got a location on it. I find out which truck that is, and I update the current location of that truck. And then that's used to basically display information to the fleet operator. So, and again, same thing. This is all done in one data node. There's no need to there's no need to get data from another data node. So that is Geode for data streaming. I think that's our 6. So I hope this has been interesting and informative. And if you take away one thing, I hope you take away that Geode is much more than a cache. Thanks very much.